All right, hey guys, so my name's Shihab and I'm really excited to be talking to you about building smarts. Now, smarts is all the craze, and there's a ton of buzz around AI and machine learning. We've got self-driving cars, we've got robots beating grandmasters at games, we've even got talk of Skynet survival, so it's all happening. Now, at Atlassian, we've been starting to think about how we can make our collaboration products smarter. And today, I want to share with you how we've been approaching this journey through a few examples. Now, let me start off by saying that I'm not a data scientist, so this talk isn't going to dive into the nitty-gritty of machine learning algorithms and tweaking parameters. There's actually a ton of great material out there, so if you've got a bit of a technical background and are looking to get started, you can actually learn the basics of classification, clustering, and regression models and start playing with some data yourself, so you can get a feel for what's possible. But this talk focuses on the product side of building smarts. So how you can use data and models to build intelligent interactions that really solve customer problems. Now, before I dive in, it's worth asking, well, what really is a smart feature? Let's start out with an example. How many of you remember this guy? Yeah, that's right. It's the famous office assistant, Clippy. Now, Clippy tried to be smart. In fact, he was really good at detecting when you were typing a letter. Every time you started with "Dear so-and-so" or you had an address in the top right-hand corner, he'd faithfully pop up. It looks like you're writing a letter. Would you like help with that? Now, even though this feature was trying to be smart by offering you in-place advice where it thought it'd be useful, it wasn't very successful. Now, this all comes down to one question. What's the problem we're trying to solve? Now, even though we might have enough smarts to accurately detect that someone might be typing a letter, do users really need help typing up a letter? Smart is a solution, which may or may not be for an actual customer problem. So when we've been thinking about smarts at Atlassian, we've been approaching it from two different sides. First up, what can we do with the data? Now, our collaboration products generates a ton of data. Issues, pages, pull requests, comments. And the larger the instance, the more users we have, the more data there is to play with. So we can start to make links and associations between the data, like who interacted with what, how are our users and content related. Now, from the other side, when we think about smarts, we really need to be crystal clear on the problem we're trying to solve. So maybe the data shows that two people interact with each other a lot, but how is that useful to know? What real customer problem can we solve with that bit of information? Now, sometimes we start exploring the data, we start playing with it to see what types of questions it can answer, and we work our way up to solving a bigger customer problem. And at other times, we start with the customer problem and we break it down into smaller, more manageable problems that we know we can solve with data. So I've split this talk up into two parts. Now, the first part is a deep dive on a single smart feature. Now, I want to walk you through the journey that we went through to build and ship a smart feature end to end, and share some of the learnings we made along the way. In the second part of the talk, I want to fly through a variety of different examples of how we're looking to use smarts, from simple rule-based heuristics through to some early explorations and experiments that we're still playing with. But let's get straight into the deep dive. Now, can I get a quick show of hands? How many of you guys are using JIRA Service Desk? Awesome. Well, you're among the 20,000 teams and counting around the world using JIRA Service Desk. It is the fastest growing product in Atlassian's history. And the crazy thing is, it's also growing within organizations. Now, for those of you that don't know what JIRA Service Desk is all about, it's a tool that helps service teams like IT and customer support connect with their customers. So it could be employees within the organization or clients outside the organization. Now, one of the key features of JIRA Service Desk is that it provides a simple and intuitive portal for customers to create and track their requests. Now, many organizations start out with something like this, a basic IT service desk, to provide a way for employees to get IT help, get desktop laptop support, request new software, new hardware, and so on. Now, JIRA Service Desk allows these service teams to define these various request types. But as the adoption of Service Desk increases within IT, the number of request types that the service team offers just explodes. And it's not just the number of request types that grow. We've actually seen Service Desk spread to other parts of the organization, from facilities, marketing, HR, finance, and so on. We've even got customers that have over 100 different service desk projects. So I'm not kidding. Each of these individual service desk projects offer a bunch of specialized request types. So it can get really hard for end users to figure out where to go. Now this is a problem. I don't even know what service desk to look in to find the right request form to fill out just to get this one little thing done. And it's actually a very validated problem as well. We've seen this come up in support requests and as feature suggestions on our public issue tracker. We even had a customer actually design and send through a mock-up of how he'd like it to work. And another fairly large customer actually hacked up their own solution for their own private instance. Now we thought, no worries. We got this. A simple way to solve this scalability problem is to add a search bar to search across all of the request types across all of these service desks. Now this is exactly what we did. And it wasn't just basic hacked up string matching. We used a standard search library which took care of things like removing stop words, like words that don't add additional meaning. So this particular request type has a bunch of text in there, but this process gets rid of words like, if, you, like, a, or, and so on. Now all of these words are thankfully removed due to this process. Now, the search algorithm also performs a process known as stemming to reduce words like printer and printing to their root form, print, for fair comparison. And the algorithm also calculates something known as the inverse document frequency of words. Now, this boosts up words that appear rare. So for this particular request type, you can see that there's a few words in there, but it's really about hardware and monitors and printers. All of the other words here are shared across request types, so they don't really add much unique meaning. Now, I guess what I'm trying to say is even this stock standard approach to search is pretty sophisticated. So we implemented it and we shipped it to our own internal service desk just to see how it would go. Now, this is the first tip that I have for you guys. Eat your own dog food. Now, what that means is if there's any way you can use the stuff you build internally before you inflict it on others, you might be able to catch a few things before they blow up. Now, the cool thing about Atlassian is that we've got an awesome feedback culture. So it wasn't long before the feedback started pouring in. That search is so broken. It never finds what I need. I spilled coffee all over my keyboard. I just need new keyboard, damn it. Now, we pretty quickly realized what was going on. If you search for new hardware, well, everything's fine. You get the right request type. But if you search for something like second monitor, well, that's still okay. It finds hardware request even though other request types might be shown. But if you search for keyboard, well, that doesn't match any of the text across any of the request types, across any of the service desks. But we know it should be a hardware request. Now, the problem is hardware request is a category. And there are only a few words in its description that describe the many things that could belong in this category. Keyboard, mouse, computer, power, laptop, desktop, trackpad, and it's not just this request type. The same thing applies for software requests, access requests, and so on. These request types, they're often categories. So we've broken down this bigger problem from I need help, but I don't know where to go, into this smaller problem. I know the specific thing that I want, I just don't know what category it belongs to. Now, this is a classic machine learning problem known as classification. So the tip here is to spend a little bit of time to get familiar with the common types of problems that machine learning can solve. Because you will get to a point where you or someone else on your team will need to recognize that a particular sub-problem has known and established solutions that you can use as starting points. So the next step for us was really to brainstorm some options into solving this sub-problem. Now, the first option we came up with was the no-brainer option. It was essentially to allow admins to add more details to the request type in the form of manually curated labels. So these hidden labels wouldn't be shown to the user, but they'd be able to boost up search. Now, the thought behind this approach was that admins might not know everything that a category would hold, but they'd be able to specify enough to improve search. But the major problem with this approach is it doesn't scale. And after we did some research with a few admins, we realized that this was going to put the burden on them to do the right thing. And some of you guys are admins out there, so you'd attest to the fact that you do have day jobs, not just administering our products. So we had to scratch that idea. Now, the next idea we had was to learn from the searches themselves using a standard machine learning classifier. So when someone searches for new keyboard, and somehow by browsing around the portal, they end up creating a hardware request, well, we can learn that. So when someone searches for keyboard again, we can use our classifier to recommend the right request type. And over time, we can learn to classify more and more of these searches as the corresponding request type. Now, this isn't a bad idea, but it doesn't really take advantage of all the data that we've already got stored in past tickets. Because even before we roll out search, many people would have created hundreds of hardware tickets about keyboards, laptops, and broken mice. So this brings us to the third idea. Treat previous issue data as classifications. So say someone searched for new keyboard, and we previously had tickets about keyboard in the past, like my keyboard broke, or I need an ergonomic keyboard. Well, we can use the request types that match the previous requests to essentially vote for the request type of the incoming search. Now, one of the neat things about this approach by using issue data as classifications is that when a classification mistake is made, editing the issue is effectively the same as relearning the classification. Let me show you what I mean. If someone searches for work from home and finds nothing, right? They might just give up and create a general IT help request. But the ticket that gets created, I need to work from home, is now classified as a general IT help request. So when someone searches for work from home again, they'll be recommended to create this generic request type, which probably isn't the best thing. What's really neat, though, is that if an agent on the service desk team updates the classification of this ticket from this generic IT help request to something specific, like a VPN access request, well, now when someone searches for work from home, they'll get presented with the right request type straight away, which is pretty awesome. So we got to the stage where we thought that this algorithm could work pretty well in practice, and we wanted to build it out to see how it would actually perform. Now, before you start iterating on algorithms and implementations, collect loads of data that you can train and test with. Now, sometimes you might already have a bunch of data, which is great. But in this specific case, we didn't want to launch with a clearly flawed search algorithm to our paying customers just so we could get a baseline. So we instrumented and we ran basic search internally to capture what people were searching for and what request type they ended up creating within a 10-minute window. Now, this gave people 10 minutes to browse around or keep searching until they found what they were looking for. And within a few weeks, we had hundreds of searches. What people were searching for and what requests they ended up creating. Now, we eyeballed this data and we saw what we expected. So people searching for specifics like computer, not finding anything useful, and then immediately after searching for hardware, finding the right request type and creating the request. So we consider both of these searches, computer and hardware, as searches that should resolve to the hardware request type. Now, using this as the ground truth data, we started to iterate on the search algorithms. Now, we used a pretty simple scoring model. Each algorithm was allowed to return up to 5 search results, and if any of these search results happened to be the correct request type, it was scored a win, otherwise it was a fail. Now, our very first baseline algorithm was basic keyword search. Now, this saw an accuracy of 31% on the ground truth dataset. Then we switched to a proper search implementation, removing stop words, performing stemming, and so on. Now, the accuracy bumped up to 42%, which is kind of what we expected. And then we got to the fun stuff. We built and tested our smart search algorithm using previous issue data as classifications. And we saw a massive improvement to 58%. But we didn't stop there. We kept iterating on the algorithm. We had over 10 different variations, like how far we should look back in time, how much weighting should we give to issue classification versus text matching, and so on. And the final algorithm we rolled with had an accuracy of 67% on our ground truth data. And when we shipped this algorithm to our own internal service desk, the complaints and feedback around search, they just stopped. Basic searches like keyboard and mouse now return the right category straight away, hardware request or desktop laptop support. But we also saw some interesting things like side effects of search. Like if you search for new employee, you actually get presented with request types that are about employee onboarding. So if you're a manager, you don't have to figure out what requests you need to create when someone joins your team. Application access, making sure they're on the right mailing list, giving them the right hardware. And none of these request types explicitly mention new employee. All right, what about something completely random, like pizza? Well, that kind of works too. Catering requests, event requests, even a team kudos to congratulate a team can be for pizza. So we reached a point where we were confident enough to ship this smart search to our customers. All right, now for the big question. How did it perform in the wild? Well, for smaller instances, the accuracy of search was around 30%. But for larger instances, it was between 48 to 52%. Now, it's interesting to see that search actually performed better on larger instances where we had more data, but where the pain of finding the right request type was also more intense. But what do these numbers mean anyway, right? Like, is 52% good, or does that mean we've got another 48% to go? Well, this data doesn't mean much in isolation because this is the first time we ship Smart Search to our paying customers. And we can definitely try to improve this using, combining issue classification and search classification, synonym expansion, and so on, now that we've got a real baseline from our customers. But this is probably a more important number for now. After we shipped the first iteration of Smart Search, the customer feedback and issues we were getting about this specific problem died down to 0. So although we can come up with even more clever solutions to this specific problem, for us, right now, it's no longer a problem that needs further solving. So the final tip that I have for you guys is to focus on the problem, not the machine learning problem, but the actual customer problem you're out there to solve. So that, ladies and gentlemen, concludes the epic journey we went through to build and ship this smart feature end to end. Now, in this second part of the talk, I want to share a variety of different examples of how we've been building, exploring, and playing with smarts. Now, let's start out with simple smarts, where you don't necessarily need to open the machine learning toolbox to build intelligent interactions. Now, how many of you guys have used app mentions before in JIRA or Confluence? Awesome, that's everyone. Now, app mentions are designed to pull people into the conversation and let them know that a specific comment is directed at them. Let's look at an example. So on this particular issue, I can't connect to the Wi-Fi. Now, we can bring in an expert like Ronald into the conversation. Hey, @Ronald, do you know if the router on level 3 is still playing up? Now, this sends Ronald an email notification to let him know that he's been mentioned on the issue, to pull him into the conversation. Now, the conversation continues with back and forth app mentions until the issue gets resolved, perhaps pulling in others as well. Now, one of the challenges with app mentions is as the adoption of the product spreads throughout organizations, the number of users using the product also increases. And it can get really hard to find the person that you want to pull in. Now, we've got autocomplete for app mentions. So when you're searching for someone like Ronald, it kind of works okay. But if you search for a more common name like David, or was it Dave, it can be really hard to know which one to pick. Now, if you consider larger instances like our public issue tracker, JIRA.Atlassian.com, where we've got hundreds and thousands of users, even a name like Shihab can appear to be a pretty common name. And if you know someone's full name, like David Wilson, you still have to look really closely to know which David Wilson you want to pick in. So this is a real problem. It's hard to mention who I want, but we can break this problem down into 2 sub-problems. It's hard for me to mention who I want when they're not involved in the issue, so we're pulling them in for the first time. And it's also hard for me to mention who I want when they're already involved in the issue. So maybe we've mentioned Mr. Wilson in the past on a previous comment, but we need to direct another comment at him again. We still have to sift through this big list. But it turns out this second subproblem is actually pretty easy to solve using simple heuristics. So instead of doing an alphabetical text search, we can prioritize search results that coincide with individuals that are already involved, like the previous commenter, or the reporter, the assignee, voters, watchers. All of these users can be bubbled up to the top to make it a no-brainer to direct an app mention at someone that's already involved. That's a pretty simple and elegant solution to this specific subproblem. But it turns out that conversations like this, where app mentions are bounced back and forth, are pretty common in practice. Across our IT, dev, and support projects, between 1/3 all the way up to 2/3 of app mentions refer to someone that's already involved. So this simple solution, even though it doesn't solve the whole problem, it solves a big chunk of it just by using simple smarts. Now, another area that we can solve the problem with using simple smarts is issue assignment. Now, as the number of people and volume of tickets increase within an organization, the job of triaging and assigning the ticket to the right person can become a cumbersome process. So the problem we're trying to solve here is who's the best person to work on an incoming ticket? Now, when an issue comes in, there's a bunch of data in there, like the project and issue type. So this particular request is for the IT team, and it's a change request. Now, we've got free text in the issue summary and description explaining that this is a task to run an A/B test on our public website. And there's more fields in there, like the priority. I mean, I'm sure you guys are used to getting everything coming in as high priority. And we've got the component, so it's tagging the issue with the high-level category that it belongs to, so public website. And we've got the optional label of A/B test. So there's a bit of data in there, both structured and unstructured. And admins can use this data for their own smarts by defining rules for issue assignment. Now, the most basic type of rule, some of you guys are probably familiar with this, is to set a project-wide assignee. Now, that means that all the issues that come into this project will get assigned to one poor soul. And it's their job to then farm out the tickets to the rest of the team. Not very smart. Now, you can get a bit smarter by using component leads. So when this issue comes in, it's tagged with public website. So you can see here, Oliver Wessels is the component lead for public website. So this issue would automatically get assigned to him, and he can delegate it on to his sub-team, or he can choose to work on it himself. Now, admins can get even more granular by using the built-in automation framework inside JIRA Service Desk. So they can craft rules like when a certain trigger occurs, if it matches certain criteria, then take action. So for issue assignment, we could craft a rule like when an issue gets created, if it has a label set to A/B test or contains the text A/B anywhere within the summary or description, automatically assign that ticket to our A/B testing guru. So that way, as soon as the ticket gets created, it's automatically assigned to the right person. Now you can get even more craftier and build rules like when an SLA is about to breach on a high priority ticket, automatically assign that ticket to the team lead. That way she can try and step in before the breach actually occurs. So we're solving this problem using simple smarts, not machine learning. We're giving power back to the admins so that they can craft the rules that make sense for them for smarter, automated issue assignment. Now, we've talked a little bit about simple smarts using heuristics and rules. Now let's move on to data exploration. I want to share some of the things that we're playing with. Now just keep in mind, most of the stuff that I'm going to be talking about is super experimental. So it might make it to product one day, or it could actually prove to be completely useless in practice. Now let's start out with that exact same problem. Who's the best person to work on a ticket? Now we've talked about user-defined rules just earlier. Now one area we're exploring is the ability to automatically suggest assignees based on past issue history. I want you guys to look at this issue. It's a real one from our own IT team. What do you notice? There's a ton of data in there. We've got free-form text in the form of the issue summary and description. We've got some structured data in the form of fields, so issue type, priority, components, request type, IT office, SLA time, reporter, channels, dates. So much data. Now we can use all of these data points across hundreds and thousands of past tickets and build a classifier that learns to predict the assignee. Now from the early experiments that we've been running on our own data, we found that we can predict the assignee of a ticket from a pool or from a team of 25 potential assignees with an accuracy of 28%. I can see some faces in the audience, so I know what you're thinking. It's probably not okay to automatically assign the ticket to someone if it's going to be wrong more than 70% of the time. But one of the things we noticed was that our classifier was able to recommend the top 3 potential assignees for a ticket with an accuracy of 58%. Now that's 4 times better than the naive approach of recommending the most frequent assignees. So what we plan to do is gently suggest these assignees and see whether the recommendations get picked up by our own IT team internally. But there's obvious areas of improvement, right? We can take into consideration whether someone's away on leave or someone's already got a high workload. But we have to ask ourselves, what else could we do with all this data? Now, there's a lot we're looking forward to playing with. For example, we can learn to predict field values, so not just the assignee, any field value. So we can interpolate them if they were missing during issue creation. So like components or labels. We can even double check if that priority field that's always set to high should be set to something else. Now, in addition to recommending knowledge articles, we could display related issues like known incidents and problems associated with that request. We can even start to predict things like how long it generally takes to solve a particular type of ticket. So we could predict tickets that are at risk of breaching SLA, or tickets that are at risk of a low customer satisfaction rating, so they can get prioritized accordingly. Now, I gotta say, exploring all this data is loads of fun, but we really need to taper that with solving real customer problems. So even though we're exploring whether we can do some of these things accurately, like interpolating field values, predicting SLAs, we're also doing some user research to figure out which of these problems are urgent customer problems that need solving. Now let's look at another product where we're doing a little bit of data exploration. Confluence. Now let me give you a sneak peek into our own internal instance of Confluence. Now in the last 5 minutes alone, 24 blogs, pages, comments, and attachments were created. So that's 24 pieces of content in 5 minutes, which is pretty crazy. Now, as the number of users that engage in Confluence increases, the amount of data and the amount of content dramatically increases. And you'll reach a point where it becomes impossible to keep on top of everything. But more importantly, it can be hard to figure out what's relevant to me. What should I be reading? Now, one basic solution to this problem is to highlight content that other people are finding interesting. So ones with many comments or likes in a short period of time. Now this is great, but I don't know if you've done this before, it actually produces some interesting behavior. Like blog posts, they turn into a bit of a popularity contest. So you can see that the most popular titles here appear to be clickbait. I'll read them out. A new way to talk about software teams. What features will we put into Atlassian Data Center? Your efforts will be worthwhile. Now these posts, they're popular because they're designed to be read by everyone, right? But there are pages out there that are relevant to me and what I'm working on. Now how can I know about those? So one idea we're exploring is to look at who you interact with socially in Confluence to get an idea of what your virtual team looks like. Now take a page, for example. It might have 3 authors. Now we can probably infer that these 3 people are somehow related. I mean, they're working on the exact same piece of content together. But a page, it doesn't exist in isolation. It's got comments, likes, links to other pages, and so on. And all of these bits of content also have authors. Now, if you collapsed out the content from this graph, you can see which authors are related to each other, some more strongly than others. Now, we started exploring this idea on our own data to see what kind of relationships it can bring up. So if you zoom in, you can see that I'm strongly connected to others in the product management team, and also a team lead that I closely work with in engineering. Now, this is just based on my interactions with content in Confluence. Now, if you expand out the virtual team for the team lead, you can see that he also is strongly connected with others that he works with in engineering. Now, we're exploring how we can use this information to power things like personalized content recommendations, suggesting individuals to follow, even recommending experts. So maybe you don't directly work with someone, but you like working on the same sets of topics. So it's a really exciting area of exploration for us. Now, all of the examples we've looked at so far are about making our products smarter. But many of these same techniques can be used to make our supporting processes smarter as well. So let's take a quick look at smarts outside of product. Now, one of the problems we have, okay, it's probably a good problem to have, we have a ton of customers. And that means we've got tons of customer feedback. But it can be very hard to figure out what our customers, what each and every one of you think about our products. So we've got several channels of customer feedback. We've got our public issue tracker, JIRA.Atlassian.com, where customers can report bugs and create feature suggestions. We also have support.Atlassian.com, where we provide one-on-one support to our customers. We run a ton of customer interviews to get qualitative feedback on our products, and also run a bunch of surveys to get quantitative feedback. But the problem is a large amount of this feedback is from the administrators of our product, not necessarily end users using our product day to day. So one of the things we introduced was an in-product prompt to allow these end users to provide direct feedback. And we ask a very basic question, a standard Net Promoter Score style question, to get an overview of what they think. How likely are you to recommend this product to a friend or colleague? Now they give us a rating between no chance in hell all the way through to extremely likely. Now, the 9s and 10s are treated as promoters, the 7s and 8s are neutral, and everything else is considered a detractor. Now, once they pick a rating, we also give them the ability to provide optional free text feedback. Now, this is pretty neat because we can start to visualize a pulse of what our end users think about our product in the terms of an NPS score. But what's even cooler, in my opinion, is that we can start to get specific feedback on what each and every one of our customers love and loathe about our individual products. But there's one problem. We have over 50,000 responses per month, and 15,000 of them have free text feedback. So even if it takes a minute to read through each one of these feedback items, that's over 250 hours of continuous reading. So the problem we're trying to solve is to figure out what our customers think about our products. And we've solved that. We've got 15,000 thoughts per month. So the real problem we're trying to solve here is how can we summarize all of that feedback? Now, our Voice of the Customer team devised a categorization framework to help draw insights from the raw feedback. We're keen to find out whether our customers were disappointed with the reliability of our product, so things like bugs and performance issues, outages, and so on, or with the usability of our products, or with missing functionality, so new feature requests or improvements. Now, our team manually labeled thousands of feedback items into these buckets, and we built a classifier to learn from these feedback items. Now, it was interesting to peek at some of the words that strongly identified with each of the buckets, like slow, broken, error for reliability, complex, can't find, setup for usability, like to, I wish, customize for functionality. So you can see that it kind of makes sense. Now when new feedback comes in, it's run through this classifier and it makes an RUF prediction, so reliability, usability, or functionality. And sometimes product managers or customer researchers, they dig into the feedback. So if they've already gone to the effort of reading an individual piece of feedback, we'll use that as an opportunity to ask them to check the RUF classification and correct it if it seems wrong. Now, our classifier can learn from these mistakes. Now, we've got to the stage where our rough classifier is right more than 90% of the time, which is pretty amazing. But have we solved our original problem? Well, in a way we have. I can't share the exact numbers with you guys, but a while ago we found that reliability was a big issue in Confluence. But we were able to turn this around by dedicating engineering efforts on performance. Now, across the board, usability is coming up as a frequent issue. So we've now dedicated teams to look into ways to simplify the core experiences of our products. And for JIRA Service Desk, one of our youngest products, we're learning that we're getting more and more feedback about new features and new capabilities. So we've got multiple teams working on adding new functionality to this product. So our team's looking to improve this feedback categorization framework even further by using similar techniques to summarize the topics within these broad buckets of reliability, usability, and functionality. For example, within the usability bucket for Confluence, learning to use the product was the #1 area of feedback, followed by creating content and then finding content. So we're on our way to solving this really important problem to help drive our customer roadmaps, our product roadmaps, using some smarts. Now, if you want to find out more, Sean, who runs the Voice of the Customer program, will be giving a lightning talk tomorrow at 2:30, giving a talk on how your insights are affecting change in 2017. Now, I know I'm standing between you and lunch, and this talk started a little bit late, but there's one final area that I want to cover, where smarts can help outside of product. Now, as our company has grown over the years, the amount of information that's flying around has just increased immensely. Right? I'm not just talking about pages and blogs. Even the sheer amount of systems we deal with has just increased. And it can get hard to find out where to even go to get questions answered. Now, as a new employee, or even as an old-timer, it's pretty daunting, right? We've got multiple instances of the same product doing different things. So it's hard to know where to even start looking for answers. So you can guess what most people do, including myself. We resort to HipChat to find someone to ask instead of trying to wade through these systems manually. Now, here are some of the common issues that the IT team get through direct one-on-one chat. I'm locked out of my account. I'm having Wi-Fi problems. Can I get a new computer, mouse, keyboard? I can't sign into the system, and so on. Like most of these questions, they have direct solutions, either on our intranet, our knowledge base, our Q&A platform, or they exist as request forms on a service desk. But it's just too hard to look across all of these things. So we've started to prototype a bot called Charlie that can help answer questions like this by querying these systems for you. Now let's take a look at a basic example. So Jerry starts a conversation with Charlie. I can't connect to the printer. I found a few articles that might help. So Charlie queries these connected systems and finds related content. 1, setting up printers in Sydney. 2, how to connect to the Wi-Fi. Now Charlie generates these URLs, so he knows when Jerry's clicked on them. So he waits for a while and asks Jerry about the last thing that he clicked on. Did setting up printers in Sydney help solve your problem? It's a bit creepy, but yeah, thanks. Awesome, glad I could help. Now that example was probably too easy. Let's look at something a bit harder. How do I get a new laptop? Now in this case, Charlie's found a few articles and also a few request forms from Service Desk. Now again, Charlie waits for a while for Jerry to do something. It looks like you created a hardware request. Was that what you were looking for? Creepiness doesn't stop, but yeah, thanks. But this time, it's a bit different. Charlie learns that hardware request is probably the best answer to this question. So the next time someone asks for, how do I get a new laptop? Well, the best response can be shown straight away. But what if Charlie has no idea what the best response should be, or what any response should be? How do I get a new swipe card for the building? Now, Charlie does his best to find anything that's related. Did any of these help you? Nope, none of these answer Jerry's question. There's a few things we could do here. We could ask that question to our Q&A platform, Confluence Questions, on Jerry's behalf and wait for someone to eventually reply. Or we could try and connect Jerry to the right team or individual in HipChat, maybe the team responsible for building access or building security. But one of the things we plan to experiment with is to ask Jerry to help train the bot. Sorry to hear that. If you do find a solution, let me know and I'll remember for next time. Now humans are super resourceful, so we expect Jerry to figure it out. I mean, if Charlie didn't exist, he'd probably be asking the person next to him, he might be doing the searches himself, he'll figure it out. Okay. So when someone says, how do I get a new swipe card for the building? What should I say? Go to reception on level 6. They've got spare cards available. Got it. Thanks, Jerry. Now Charlie can remember that bit of new information for next time. Okay, let's up the game one final level. Another area we're experimenting with is the ability to ask structured questions, like, who is Vincent? Okay, we can use basic natural language processing to figure out this is probably a question about a person named Vincent. So we can query our internal people directory. Which Vincent did you mean? All right, let's pick one. Vincent Wong is a product manager on the JIRA service desk team. Now, Charlie's been kind enough to give Jerry a link to Vincent's profile online so we can find out more information about Vincent. Or we could just ask Charlie. Where does he sit? Now we're asking the question where about the current person that's in context, which is pretty amazing. Now in the future, you could ask questions like, what is he working on? Is he free to meet up for lunch tomorrow? And so on. Now it's still really early days for Charlie. It started out as an innovation project, and we're continuing to explore and experiment. It's going to be interesting to see if we get to a level of accuracy and a level of user experience to really solve that customer problem of being able to answer internal questions. I've covered a variety of different examples today. Hopefully this gives you an idea of the ways we're looking to build smarter collaboration products. Now there's a lot more we're working on, and every innovation week and hackathon we run produces more and more examples of smart capabilities. Now hopefully this has inspired some of you to start playing with data yourself, to see what types of questions it can answer in your own organizations. And for the few of you out there that are already super excited about the possibilities of using data to build smart solutions, just make sure you take that one step back and you're crystal clear on the problem that you're trying to solve. Don't just get carried away with building smarts for the sake of it. solve real customer problems. Thanks, guys.